Hey guys, today's lesson is 2.5, last lesson of the chapter. This is further applications of right triangles, aka some more story problems and bearings. And so what you need to know first of all is I have a definition here for you. Bearing, it's an angle that's measured clockwise from the north direction. So we have a couple different things about what we've been doing with bearings or with angles so far and how bearings kind of negates all of that. So all the stuff that you've been learning about unit circle and how to graph angles with degrees, kind of throw that out the window because a bearing actually has north, south, east, west direction attached to it. And the way that you always do bearings is that you start with your angle at north and then you measure it clockwise, so like the angle is going around the clock, from the north direction, and that is how you're measuring angles just for bearings. So the unit circle stuff is still the way that it is, but a different section in this chapter is bearing. So in this case, 32 degrees, we're going from north 32 degrees. In this case, 164 is almost 180 degrees from north. 229 from the north and 304 from the north. So we're always going clockwise from the north direction. So it's important that you remember or that you're familiar with north, south, east, west, because that's how we're going to draw our pictures. North, south, east, west, just like in a map. But a lot of the directions have north, south, east, and west attached to them. So you need to be familiar with what that is. Okay, so I'm going to do these two examples about bearings, and I'm going to save problem number 3 for tomorrow in class. And there are 6 Math Excel questions that have to do with bearings, and I am anticipating you guys to have questions, especially at first, and like struggle to draw the picture, but as you do more practice, you will get better at it. But they're a little bit tough to get the hang of. So I'm going to start with the first one. Radar stations A and B are on an east-west line. So this is kind of a basic, simple example as an introduction to bearings. I'm going to put a dot for A, and I'm going to put a dot for B, and because they're on an east-west line, I can put them directly across from each other east-west. And they're 3.7 kilometers apart, so I'm going to put a 3.7 here. Okay, so station A detects a plane at point C on a bearing of 61 degrees. So this is the new thing. We have a bearing of 61 degrees. And what I'm going to have to do with that is draw a line from A north, because that's how a bearing always starts. And then if I go 61 degrees this way, that's where my angle finishes. Okay, so I'm going to put a 61 here. That's how you do bearings. And then it says station B simultaneously detects the same plane. So I do have a plane up here somewhere. I guess I'll put a dot right here, and I'm going to draw my best airplane ever. Nailed it. There's another wing somewhere. Okay, so there's the airplane. Station B sees the same plane on a bearing of 331. Okay, this is going to be kind of strange, but this is north. And just to do 331 kind of the way this one is, I'm going all the way around the circle, and I'm going to end up drawing my angle this direction. Okay, so this is going to be weird, but 331 degrees is past 270, so like that way. 331 was out here. Therefore, I think I can find what this angle is. I'm just trying to fill in my picture. So that would have been a full circle had I started here and gone all the way around. But I stopped a little bit short and I got to 331. So that actually makes this angle 29. So I'm going to fill that in. Okay. And so if you think about what you know about north, south, east, west, this is north. This is east, west. So do you see that? Keep this in mind. This is going to be true for most of the pictures that we're going to draw. This is a right angle. Therefore, I can figure out that this angle here is 61 degrees because it makes a right angle. And that is because north and west makes a right angle. Okay? And then let's see what else can I figure out. If that's going to be 61 degrees, I can do the same thing over here. I have north and east. So I have another right angle in this spot, which means that I can figure out that this angle is also 29. And then remember we have a triangle here, so 29 degrees, 61 degrees, what is this? That, believe it or not, mathematically, when you subtract, ends up being a right angle as well. Okay, so this is a picture, and drawing the picture and filling in all the pieces really takes quite a bit of time and attention to detail. But this question, we haven't even answered the question yet. Find the distance from A to C. So I need to put an X, so my airplane was C up here. From A to C, my X goes right there. Trying to find that side. Okay, so look at this triangle that we have right here. I have a right angle here. This is my hypotenuse. And I'm trying to find this side. So again, using sine, cosine, and tangent, I'll use the 29 degrees here, and I will use cosine because I'm looking for adjacent and I have hypotenuse, and that is what I'm going to go with. So cosine of 29 equals my adjacent side over my hypotenuse side, and just doing some simple calculations in the calculator, that gives us x equals 3.236. And this is what, kilometers? Okay. So there's our answer. Just as an FYI, you also could have used this angle and done the sine function. So you could have done sine of 61 equals x over 37. I will write that. You don't have to, but maybe you were wondering why I used cosine. You could also use sine of 61 equals x over 3.7, and you still get the same exact answer. And the reason for that is, do you know? Do you know? This is cofunctions. So remember how we had you memorize a bunch of stuff about cofunctions? Remember how cosine and sine are cofunctions, and they differ by, you subtract from 90 to find the other one, they're complements. So here's a real live picture of why cofunctions are the way they are. You can use this angle with cosine, or you can use this angle with sine. Okay? So that's the first one. And like I said, that was kind of a basic drawing of a picture. That's how bearings kind of start. Problem number 2 is much more complicated and complex, and that's why that's the only other problem I'm going to do on this video. But then we will do number 3, which is a little bit more simple, but it's a different type of story problem. We'll do that one in class, okay? So I'm going to go to number 2. All right, so this is problem number 2. Starts out the bearing from A to C, so it doesn't tell us if they're on an east-west line or north-south or anything, so they're going to be on a diagonal, is south 52 degrees east. So that's a little bit different because they specified a starting point. That means you start from the south direction and move towards the east 52 degrees. So I'm going to start with that. I'm going to draw a big line here. I'm going to put A somewhere on it. And I'm putting A in the middle as opposed to the top or the bottom because I'm probably going to be using north and south direction. So from the south direction, which is here, move towards the east direction 52 degrees. And that is where C is going to be located. So I'm going to draw 52 degrees, puts my angle here. And I'm going to put a C down here. 52. So I know I said that bearings start from the north, and that's if it's not specified. But in this case, they're specifying start from the south, move 52 degrees towards east. And remember that east is towards the right. We'll think about it like looking at a map. And the bearing from A to B is north 84 degrees east. Okay, so that's a normal type of bearing like we did in the first problem. From the north, move 80-something degrees this way. Okay, so I'm going to draw here. This is 84, again towards the east direction. And this is B out here. Okay, so that's 84, that's 52. I know right away because this makes a straight line, I can figure out what this degree is because you know I'm going to connect my triangle and I'm going to need to figure out all the pieces. So I think it might be useful just to figure out what this angle is. So 84 plus this should make a straight line. So that actually gives you 44 degrees. I'm just going to plug that in now because I think it'll probably be useful in a second. Okay, so that takes care of the first two bearings. The bearing from B to C is south 38 west. Okay, so I need a south direction. Keep in mind that this is going to be parallel to this, even though I didn't do the best job of drawing it. But from the south towards the west, which is left, 38 degrees. So this direction, 38 degrees. Okay, so So not really the best job of drawing, and a lot of times what you'll start to like realize is that you might need to like erase or like slide a point over sometimes, but this was 38 degrees. Again, it was from the south, and I moved to the left 38 degrees. This line and this line are parallel. Those are both my north-south lines, even though my B line doesn't really look, maybe I'll make that look a little bit straighter. Okay, this is how you do bearings, you guys. It takes a little bit of time to be able to draw really nice pictures. Sometimes you have to erase. Okay, so a plane flying at 250 miles an hour takes 2.5 hours to go from A to B. So my plane's going this direction, but it didn't tell me how far it traveled. It did tell me the speed and the hour. So let's go back to like chapter 2, or chapter 1, I mean, when we learned how to do conversions to figure out an actual distance from A to B. So if it takes 250 miles per hour, if I multiply that by 2.4 hours, I'll be left with, hours cancel, 250 times 2.4 is 600 miles. So I now have a value here, 600 miles. Just filling in as much info as I can. This is a way to make a problem like that more complicated, to not give you one of the directions or distances, but rather see if you can figure out what the distance is by giving you some more pieces of information. Trying to find the distance from A to C. Okay, so that's what I'm looking for. I'm going to highlight it just because that's where I'm looking. And now I need to figure out a couple more angles. In my triangle, the only thing I have is this 44. I know there's probably got to be a right triangle somewhere. Is it this angle or is it this one? It's hard to tell by my picture, but let's use a little bit more info. Here's a tip. If you were in honors geometry, you for sure did this. If you were in regular geometry, you might not have seen anything like this before, but could you draw a line like so through C, parallel to your north-south line, so that we can fill in some more of the angles? So I just constructed a line right through point C so that it was parallel to all my other north-south lines, because what I'm going to be looking for, you guys, is alternate interior angles. Do you remember that? We talked briefly about it in first chapter, but see this 52 right here? It also can go right here. That's called an alternate interior angle. If you look at this north-south line, this north-south line, and this transversal. So if 52 is here, that means a 52 can go here. Okay, so I'm going to put in my 52 right there. And for the same exact reason that I drew that, look at this north-south line and this north-south line with this transversal. So if this is 38, you can put 38 also here. These are alternate interior angles. Let me zoom in a little bit. 38 goes there. Now, did you notice that makes this a right angle? It doesn't look like it according to my picture, and a lot of the times it won't look like it, but that's okay. The reason I constructed that line is so I could use some alternate interior angle stuff. If this angle here, maybe I'll use a couple different colors here. This angle and this angle are alternate interior angles. Furthermore, this angle and this angle are alternate interior angles. So if you remember that from geometry, the trick to this bearing problem, which again, I told you this one was a more complicated one, is to construct that line through point C so that it's parallel to your other north-south lines so you can fill in some more angles. So here's my right angle. Just out of curiosity, can we figure out what this angle is up here in the triangle? Yes, this one's 90, this one's 44, that makes this one 46. So now, you guys, I have to figure out what it's asking me to find. Oh, I already highlighted it, the distance from A to C. So I need to find this. You can put an X there. I have my hypotenuse again. Remember, that's across from the right angle. The hypotenuse is 600. So I will use cosine of 44 equals the adjacent side over the hypotenuse side. So X over 600. So I'm using cosine 44 equals X over 600. Yes, you also could have done sine using 46 and the 600, because this is your opposite side of the 46. You would get the same answer. But our final answer, after you multiply that and get the calculator, make sure you're in degree mode. We have 431.604 miles. That one was a challenging example. Like I said, you guys, I'm going to give you about 5 or 6 more to be working on using Math Excel starting tomorrow in class, and I will answer questions and help you draw the pictures because it does take practice and it takes time and it takes some erasing, as you could see. But bring your questions to class on these two. We will do number 3 in class tomorrow, so leave that one blank. And now the chapter is over and you're done watching chapter 2 videos. Good job. Have a good night. See you tomorrow.